I can.
Okay.
Good. And guy number 3. Okay. This is the conference for the phase number 3 of the course Computer Vision. We move forward into one of the most exciting and practical stages of the learning process. This is object detection and motion tracking in videos. This phase somehow marks as a turning point in your understanding of computer vision. Until now, we have studied the fundamentals, how machines interpreted visual data, how images are processed and segmented, how algorithms track information. Now, in this step, we go further. We bring the concepts of light. You will design, you will implement, and you will analyze a complete system capable of detecting and tracking objects in video sequence. A skill that forms the foundation on many applications in modern technology. The purpose of phase
The documents in the Teams 3 documents
are the references. Yes, these are the references.
Are examples. Are examples
No.
About the activity.
Yes, in somehow yes. In somehow yes. The documents included in the library, I have shared the three of them. This one, no. I have shared an IoT monitoring system based on artificial intelligence. I have shared the efficient mining narrative-based data streams for advanced computer vision. And I shared this one, the last one, the computer vision driving forest with 5 small recognition. There are 2 that are missing. This one, I don't know what happened with the library. I need somehow the library, this document is no longer the library, so I don't know because at the beginning of the semester it was available, but somehow I don't know why they removed. And this one, the prominent solution for solar panel defect detection. Yesterday was a problem with one of the platforms, the Springer, I guess. And I couldn't download the paper. I guess it will be available soon. Okay. Let's carry on. What is the purpose of this activity? The purpose of this activity is, of a day of the phase number 3, you should be able to integrate feature extraction and tracking methods, as well as data grouping and tuning techniques to develop computer vision algorithms capable of real-time detection and motion tracking. In other words, the purpose.
Okay. Detection moving objects.
Yes.
In the past
Yes,
activity, in the past activity, only detection feature transformation of the photo, but in this activity is object detection
The movement, yes.
and the form and the form of the objects.
And somehow you need to draw some lines around the object to define whether it's I don't know, a person, a vehicle, or whatever it is. Somehow, but it's up to you. The purpose is only to detect the object and how the object moves through the video.
Okay.
Okay. So, somehow as well, you will perceive how frame by frame, yes, the system could recognize patterns at how it follows an object's trajectory as it moves across the scene. That is what we are going to do. Obviously, this principle is applied to autonomous vehicles, video surveillance, how traffic control systems, sport analytics, and some human-computer interaction. That is what that is.
Okay. Other question. This activity um, is necessary to implement Arduino or only only the programmation in Python,
Yes.
or is necessary to implement Arduino with sensors.
No. Sensor, you don't need to implement anything. You just need to you need to select the video data set.
Data sets.
These are the steps. Yes, data set. Or a data set or a video that you need to perform. Anyways, depends on you.
Okay.
The data set has one main characteristic. Objects can be clearly detected and tracked. That is the first one.
Okay.
Okay. Let me show you. This is an example that I have. The file is larger, so it will take some time to present the video.
Okay.
This is my example. This is the video that with. Obviously, it depends on you. You may use public data sets. There are some particular data sets as COCO and MMT challenges of any relevant video that contains moving objects. In case vehicles traffic, you can choose people walking, you can choose sport movements, whatever you want. But make sure that you chosen that file data set has sufficient clarity and variability for testing your algorithm. This is my example. You can choose whatever you want, okay? But important, have clarity and variability. This one is 1 minute line. Obviously, we are working with video. You understand that it's helpful for use somehow. I will recommend to use small videos, small length videos somehow. Or short videos if you want as well. It depends on you. The second step is you will implement an object detection pipeline using retaining model. You can use YOLO, you can use SD, or you can use basic segmentation, thresholding or background subtraction, whatever you want. Or you can complement the YOLO or the SSD with basic segmentation techniques. I mentioned there in the guide, thresholding or background subtraction to separate moving objects from static backgrounds. Good? Any questions?
No, thank you.
In this form, no. Okay. Or when you do that task, you will form the backbone of your detection system, because the stage that recognizes and isolates objects in every frame.
Okay.
Okay. Step number 3. You need to apply motion tracking techniques. Once the detection is functioning, you need to integrate a motion tracking algorithm. Which tracking algorithm you can use? You can choose from Centroid Tracking, to link detected objects across frames. You can use Kalman filtering to predict position based on motion models. Or you can use Optical Flow to analyze pixel level movement. As you know, what you can guess, the object is to achieve a smooth and continuous tracking of the same object through the video. If you detect the object, and now you have to follow the object. Good?
Okay.
Any questions so far?
No. If I have question, I'll be right in the teams. In the teams, yes.
Good. Perfect, yes. No worries, no problem. Step number 4. After the system runs, you need to analyze the results. Usually you need to present in the document visual outputs. You need to present frames showing bounding boxes and trajectories. You select the frame and you follow that frame with some lines. You need to present object paths, trajectories, and motion trails somehow. you need to present the counting results. This is the number of moving objects in the video. You will in the video I presented to you. It will be a lot of moving objects, and you need to perform some metrics, such as detection accuracy and tracking precision. Interpret what these results mean. You need to answer to the question like, how well did your system follow objects? And what challenges appeared with occlusions or overlapping movements? You need to answer that question as well. And step number 5, obviously, is to prepare a collaborative report. As usual, 1,000 or 1,200 word report. Structured.
The collaborative report is short.
Yeah, it's quite short. 1 or 2 pages, no more than that.
Thank you.
As maximum 3 pages, no more than that.
Okay. I believe that it's very important the file in Python in the platform in the platform Google Colab.
It could be Colab, or it could be whatever you.
I work in Google Colab. I share in the past activity. I share with you the Google Colab with Python with Jupyter Notebook.
Yeah.
In this project, or excuse me, in this activity, challenge 3, I can the same is I can send the activity in Google Colab too.
Yes, it is possible to send the activity in Google Colab, but you need to include as well the video, the original video, and I will run the code. Obviously, I will include the video within the Google Colab project. I will run the code in Google Colab, and I will show me the results in the video.
Okay, perfect.
But just to let you know, Google Colab could have some restrictions for this kind of activity. It could have, because I didn't use Google Colab for this one. I wanted to use MATLAB just to change the programming activity for me. And this,
okay.
I'm working with.
One moment.
Don't worry. If you want to say in Spanish, okay.
I can to work in the MATLAB online.
Yes, you can. Yes, you can work in the MATLAB online, but remember, it could have some restriction as well. That's the problem, because most of the toolboxes are not available in MATLAB online, or are not available for the Google Colab section. That is the problem. The toolboxes needed for this activity could not exist or could not be included in the online version. That's the problem. So you need to keep that in mind and to develop the system according to restrictions that the system or the platform that you are using right now.
Okay.
Okay.
And Professor, your advice some program or different of the cloud?
No, not necessarily. Because if you have the platform available online, it's fine, but you need to work with whatever you have. If the toolbox that you need is not included, you need to program a little bit more. That's the thing. Because you need to implement the code to run the system in that way. For instance, tell me.
I come to the MATLAB of the university, UNAT. I don't remember how to ingresar. I don't remember how coming in the MATLAB the university.
Let me find that information for you. I will ask in the university for them to share with you the credentials. Okay, because in this moment I'm using another licensee for another university that I work with.
Okay.
But I think, and I'm not sure that the UNAT has a complete licensing from MATLAB. But obviously I don't use that one. I use the one that I use it for all my time as a professor in the other university. That is why I don't have the answer in this moment. But I will find that information for you. I will let you know which are the credentials. Then I guess it will be your email address and the same password, but they will need to give us the licensing number for being able to download the MATLAB application into your computer and to work with the licensing in your computer. Okay. But I will ask to the university for that credentials. But you can start working with Google Colab as well, because Google Colab, it depends. If I don't have any kind of information for you, just I recommend to work with Google Colab. Because Google Colab works with the licensee that we have in this moment for the email address.
Okay.
Okay.
Thank you.
This is a small example that I did for this activity. I developed this example in MATLAB Online. Please remember that MATLAB Online has some restrictions, in particular for video toolboxes and for another motion detection as well. So I need to code or put a little bit further with the code. This is motion-based detection and tracking. The purpose and design, the scripts, what we do, the scripts is builds a full pipeline for the detection and tracking and runs in my lab online. It's not heavy, deep nets. What it does is it reads the video, it detects moving objects via background subtraction, the one that I mentioned previously, this one, the background subtraction. I use this solution. It cleans as well detections with morphology, applies psi aspect filters. It tracks the objects across frames using the Centroid Tracking. Data association. It draws as well ID. It trails and counts like crossing, direction aware, and export the annotated video. It is possible with MP4 or AV formats. And it generates as well two CSV track history and count. I'm going to pass it for you. Let me download the file. So I'm gonna pass you by the chat. Through the chat, I guess.
Okay.
My computer exploded. I don't know. It doesn't work. It doesn't work. It doesn't want to work. Okay. I will pass that document later. Don't worry. I will pass to you the file later. So I don't know if this is not working. Okay, but I want to present the code. Can you hear me?
Yes.
Okay, key parameters that you can tune. So,
Parameters.
these are the parameters that you can tune. Video file, obviously, this is the path to the video that I have previously showed to you. I have uploaded the video to the MATLAB drive. This is the video that I shared with you previously. What else we have here? We have here as well.
In the example, of the cars, what is the result?
At the end, you will see every single car with a frame. You will have the how many vehicles are in that moment and where is the direction of the movement.
Okay.
And here is some part of the configuration. The foreground model, we are going to use non-Gaussians, non-training frames, and learning rate. This is for the foreground model.
Okay.
For the growth filters, we are going to use these variables. We're going to use mean blow area, max blow area frag, mean aspect in max aspect. For the tracker, we're going to use these ones. A segment mass distance in pixels, max track age in frame, and the trail length, we are actually working on 3 frames per second. Obviously, we save the video after processing, and in somehow we write some annotations. We save the files of the that we have as a CSV, and we use the last 2 variables as a content lines. Use content lines, content line points. If it is empty, it creates an horizontal line of 60% video height. Obviously, what do we use all these variables? We need to have motion detection, obviously is noisy. We need to consider morphologically mask geometric features, remove shadows, small flickers, maybe high-end mask. What I do in this example is try to set the tracking as simple as possible. As simple but robust for online environment. Remember that online environment, we don't have GPUs. We don't have graphical phase unit. So we use only as robust as possible with the restriction that we have MATLAB online. And the content lines, as I mentioned, only gives a practical metric. Up, down, lines, up, down, flows, like that. The next part is the initialization. We need to validate the video file, and we need to open the video reader. So here is the video file and the video reader. Here we create the content line, it's not provided. We build a foreground detector as well. And we prepare the persistent containers, some containers that we need to use. We need to use tracks, Obviously, we need to select this one as a structure right with ID, with B-box, with Centroid, with age, with invisibility, count, with label, with color, with trail. We have included as well the all track history. That is a table of trying ways and contains some information like IDs, control, label, speed. And we have as well the counts ups and counts down. We have as well the video writer. In this part, we trade MP4 within the program. If MP4 is not supported, which usually passes with online my life, we try to move the format to motion JPEG AV, and the file extension is chosen to match the working profile. It depends. In this part, we will depend on the capabilities of the Madline online licensing that we will have in the university. Okay?
Okay.
Okay. The next part is the main pipeline. It has a lot of code, but the first part, this one. This one is the vision foreground detector. And in this part, we return the moving foreground as a binary mask. If for any reason numeric, this function in binaries convert that numerical to its logical. The next part, this part, is used for morphologic and cleanup. Is how we try to remove noise. Try to fill holes. We try to connect fragments, and we try to delete tiny loops. Next part, prompts. This one. What we do is keep blows within area aspect bounds. What we do is convert the cleaned mask to a set of candidate objects. We use a filtering function considering area and aspect ratio. We create as well different arrays like B boxes, like sense, and labels. These are arrays that file on the information that we are finding. We follow with the tracking. And the tracking, what does is all the data association. If there is not active tracks, all detection becomes new tracks. Else, We compute the cost matrix between each tracks regarding centroid and next detection centroid. That is the Euclidean distance somehow. And we do as well the greedy assignment peaks for its mobile distance. But why do I use greedy assignment? In somehow because it's simple, it's fast, it works well when objects aren't too dense. And later on, you can upgrade the code to another algorithm if needed. You can use the Guardian algorithm. It depends on what you want what algorithm you want to use. It's up to you. This part. We need to do the track update, and we need to do the history. For a segment trust, we need to update different things like VBOS, Centroid, Edge, consecutive, invisible. We need to estimate as well the speed of the object that we are tracking, and we use a pixel displacement between two centroids. Somehow we are measuring pixels by frame. We update the whole track history as well, using frame, ID, CX, CG, label, and speed. And if we don't have we have assigning tracks, we increment some variables like age, consecutive, invisible, and other elements. For new tracks, we initialize a struct with a new ID. We assign the random color, and we append initial history row. Later, we do like the counting line crossing, the direction of the objects in movement. This is the counting line crossing. And we finish with the visualization and the writing. Obviously, we draw the counting line. For each track, we draw a V-box and we draw the trail as connected segments. We update the video, annotate it, and we close the writer, and we export the CSV files needed for the paper that you need to present. And we have some another functions, the local functions. We have the greedy functions. We have other functions like the segment cost. We have the orient, the on segment, and we have the trade to lines, other functions needed for the system to. And if you run this code, remember that the video that we are using is not a short video. It's heavy, it's 175 megabytes. So the code will process every single frame of the video and will work on that video, and as a result, we will have an annotated online version of the video. but it will take, for me, it will take 1 hour, something like that, to run this code within that video. Obviously, I cannot show you the results in this moment, but you can test the system on your own. So as you know, I have played the running, and we are somehow revising the video and annotating the new version. You will see that the resulting video is increasing in size. Obviously, at the end of the processing, we will have the video working with the frames in every single object and the trails for the following the objects of the cars in the video.
It's running. It's
It is
running.
running, yes. It's running. It will last
Running.
like 1 hour somehow. It depends on the size of the video that you have choose. That is why I recommend to use short videos, the YouTube shorts video. It depends.
Very short.
Any question?
The video, 1 minute max.
Yeah, no more than that. No more than that. Actually, it will be like 30 seconds or something like that. It will be more than enough. It depends on the machine. Obviously, if you are working with an online platform, it depends on the machine. It will depend on the speed, the internet speed. Obviously, it will depend on the licensing that you are allowed to work with. It depends on many things. But my recommendation, yes, you can use Google Colab, you can use MATLAB online, but you better use Python, native Python, or the desktop version of MATLAB. For me, it was just an example. I wanted to test the online version of MATLAB to see how it works.
Okay.
Okay. That's all for me. If you have any question, please send the question through Teams. As soon as we finish, as soon as I finish, I will send you this file for your reference.
Thank you.
Any other questions?
Teacher, do you share this file with me?
No,
Only
yet.
reference. Okay.
Only references, yes. As soon as I finish this meeting, I will share this document with you.
Okay.
And as you see, the system is running. The size of the video is 175, and it is processing just 27 megabytes. In about 7 minutes. No more for today. Thank you for your attendance.
It's very interesting.
Yeah. And we can share to Spanish.
For my I am a student IoT, and for me It's very important